Today, I have the pleasure of presenting you with a study titled The Piercing Veil of TVL, DeFi Reappraised. This paper is co-authored with Dr. Yebo Feng from Nanyang Technological University, Professor Jiahua Xu and Professor Paolo Tasca from University College London and Exponential Science. My name is Yichen. I'm currently a PhD candidate at University College London. So what is total value lock or TVL? TVL is a key metric in decentralized finance or DeFi. Similar to the concept of asset under management in traditional finance, it presents the total value of assets staked in or held by a DeFi protocol, indicating the size and popularity of DeFi ecosystem. TVL figures are reported by the DeFi tracing platforms, with DeFi Llama being the most widely recognized one. On the right-hand side, you can see a screenshot of the DeFi Llama TVL dashboard. In this study, we examine the double counting problem in TVL, which originates from the inherent composability of DeFi. DeFi composability refers to the ability of one DeFi protocol to accept tokens generated from another protocol seamlessly, allowing DeFi tokens to be chained and integrated to create new tokens and financial services. On the right-hand side, we present a flowchart illustrating the complexity of user behavior in DeFi ecosystems. Let's walk through an example. Suppose I have $1,000 worth of Ether. I can deposit it into Lido to generate $1,000 worth of SDETH, allowing me to earn staking rewards and maintain my liquidity. Then I can further deposit the $1,000 SDETH and generate $1,000 WSDETH. Cross-protocol staking is also possible. I could deposit my WSDETH into MakerDAO to generate $571 DAI. Based on the DeFi composability, I could repeat this wrapping operation multiple times to maximize my yield and maintain my liquidity. Now, if you look at the flowchart, the gray shading represents the $1,000 initial value I deposit, while the green shading represents the TVL of the entire ecosystem. As shown, the TVL ends up being around 5 times the initial value deposit. This example highlights a critical point. TVL can be artificially inflated through recursive wrapping without introducing new capital. This could mislead users, investors, and researchers, especially since many financial decisions and academic studies rely on TVL as a core metric for DeFi protocols evaluations. To make things even worse, most DeFi tracing websites report only the inflated TVL without revealing the accurate underlying value. To further understand the double counting problem, we identified 2 types of double counting: intra-protocol double counting and inter-protocol double counting. Inter-protocol double counting refers to the situation where derivative value is counted multiple times across different protocols. This often results from 2 common operations: wrapping and leveraging. To better understand this, let's decompose the large flowchart from previous slides and take a closer look. On the right-hand side, we present the flowcharts illustrating the mechanisms of wrapping and leveraging, along with their TradFi analogies. Let's start with wrapping. Showing by the subfigure A, wrapping means DeFi users deposit existing tokens, including token that has been wrapped, into smart contract to generate new tokens. For example, SDETH is deposited to generate WSDETH, and then the WSDETH is used as a collateral to borrow DAI. In this process, both original SDETH and wrapped WSDETH are counted into TVL. As a result, the same value is effectively counted twice due to the 2 levels of wrapping. This mirrors the TradFi example shown in subfigure C. A credit-worthy person lends money to a borrower and issue a note. The note itself becomes a financial asset. Because of her strong creditworthiness, She can then use that note as collateral to borrow money from a bank. Now, let's move to leveraging. It means invest with borrowed asset, shown in subfigure B. Here is an example. A user starts with DAI worth of $2,000 and uses as a collateral to borrow $900 of Ether in Aave. The user then goes to a decentralized exchange or DEX to swap that Ether into $900 new DAI and redeposit the DAI into the Aave. This process can be repeated, creating a leverage position and increasing TVL. This is similar to leveraging in traditional finance, illustrated in subfigure D. A person can use her real estate as collateral to get a loan, and then reinvest that loan into more real estate. Again, we see the same capital being reused in circles, artificially inflating balance sheets or TVL numbers. To illustrate the TVL double counting, we use a balance sheet approach to describe the financial conditions for each protocol. The aggregate value locked can be regarded as a significant element on the asset side of a DeFi protocol's balance sheet. In the context of a DeFi ecosystem, we apply the consolidated balance sheet to illustrate the financial status on an aggregated basis. This type of balance sheet represents the combined financial position of a group, presenting the asset, liability, and the net position of both the parent company and its subsidiaries of those of a unified economic entity. By employing the principle of non-duplications using consolidated balance sheet accounting, where accounting entries that are recorded as assets in one company and as liability in another company are eliminated before aggregating all remaining entries. We can effectively eliminate instances of double counting within a DeFi ecosystem. For the wrapping scenario, when the user deposits the $1,000 SDETH into Lido to generate $1,000 WSDETH, the value of the DeFi ecosystem is $1,000. However, if we further deposit the receipt token WSDETH from Lido into MakerDAO to issue another receipt token DAI, the TVL will be $2,000 under the traditional TVL measurement. The balance sheets are expanded and the TVL is double counted due to the existence of the WSDETH. In the consolidated balance sheet, the TVL is adjusted to $1,000 after eliminating the value associated with the WSDETH. For the leveraging scenario, suppose we have $900 Ether in Aave, 1,800 Ether and $1,800 DAI in Uniswap as the initial liquidity. A user used $2,000 DAI to borrow $900 Ether in Aave. Immediately after this operation, the TVL of these systems rises to $5,600. Then, when the user swaps $900 Ether back to 900 DAI and further deposit into the Aave, the TVL of this system will be $6,500. However, when we examine the consolidated balance sheet, which reflects the actual economic value in the system, the true TVL remains at 5,600. This discrepancy highlights how leveraging across protocol can inflate TVL matrix, even though no new capital is introduced into this system. When we evaluate the double counting problem with a single protocol, we need to consider the intra-protocol double counting. Since we do not focus on the cross-protocol wrapping and leveraging, consolidated balance sheet is not useful in this case. We employ the account perspective balance sheet to describe the change of financial conditions. We can find that for DeFi users, wrapping does not change asset value held by the user, while the leveraging is nothing but expanding both sides of the balance sheet. Therefore, the differences between the user's total receivable and total payables are the initial value deposit into the DeFi system. For the existing methodology to address the double counting problem, DeFi Llama proposed the DeFi Llama adjusted TVL. DeFi Llama adjusted TVL is calculated by first aggregating the TVL of all eligible protocols and then summing the TVL across all blockchains, where protocol eligibility is arbitrarily determined by DeFi Llama, whose validity we challenge. To thoroughly address the double counting problem, we propose the enhanced measurement framework, Total Value Redeemable, or TVR. Total value redeemable is defined as the token value that can be ultimately redeemed from a DeFi protocol or DeFi ecosystems. For TVL, we include the value of plain tokens, which is the tokens without underlying tokens, as well as the derivative tokens, which is the tokens with underlying tokens. For TVR, we only consider the value of plain tokens. For protocol level TVR, we calculate it as the difference between the total payables and the total receivables for users' balance sheet. Then we empirically measure the TVL and TVR for the entire DeFi ecosystems. On the bottoms, the figures shows the line chart for the unadjusted TVL, which is the red line, the DeFi Llama adjusted TVL, which is the blue line, and the TVL, which is the black line. Our measurement finds substantial double counting in DeFi, which is represented by the discrepancy between the red line and the black line. Meanwhile, DeFi Llama adjusted TVL cannot actually reflect the true value of DeFi, which is shown by the gap between the blue line and the black line. We also empirically measure the protocol level double counting for Lido and Aave. And on the bottom, the figure shows the total receivable, total payables, and TVR of Lidos and Aave V2 in Ethereum. The green area represents the value of total receivable, the red area denotes the value of total payables, and the blue lines illustrate the protocol TVL, and the black line denotes the protocol level TVR. We can find substantial intra-protocol double counting in both Lido and the Aave V2, which represented by the discrepancies between the blue line and black line. Next, we visualize the decompositions of TVL. We can observe that the dominance of the top four protocols increases following the Luna and FTX collapses, while the double counting proportion decreases after these events. We also implement network analysis for the systems of the 6 representative protocols. We observe that both TVL and TVL to TVL ratio of the protocols, excluding Lido, decreases from the point when TVL reaches the maximum value to the collapse of Luna and FTX. We further conduct the sensitivity test for TVL and TVR in terms of the Ether price change. We observe that the TVR is a more stable metric than TVL, especially during the market downturn. A 25% decline in price of Ether leads to a $1 billion greater nonlinear decrease in TVL compared to TVL. Similar to the money multiplier in traditional finance, we construct the DeFi money multiplier by dividing TVL by TVR to quantify the level of double counting. And we also shows the Spearman's rank correlation coefficient between the macroeconomics indicator, cryptocurrency market indicators, and DeFi money multipliers. We can observe that the DeFi money multiplier is negatively correlated with VIX, the traditional finance money multiplier, and positively correlated with CPI, Ether price, and the cryptocurrency in market index. Then we also show the TVL analysis of some niche chains. Compare it here, especially for the Hedera. Compared to the networks in Ethereum mentioned, Hedera definitely has a simpler token wrapping network, thus experiencing less double counting under the TVL framework. And here are key takeaways. Due to its susceptibility to double counting, TVL is a flawed, manipulable metric for DeFi value and performance. DeFi value can be more reliably measured through TVR using the accounting principles. TVR is more stable during the market downturn than TVL. DeFi multiplier can be constructed analogous to the TradFi multiplier. DeFi multiplier can be a very good proxy for the protocol complexity. And thank you very much.